Hi everyone, and let's take a look at number 17. Consider the following function. G of x, which is a piecewise function. The first piece is going to be x times the absolute value of x minus 1 all over x minus 1 when x does not equal to 1. And in the second piece of the piecewise function, it's going to be 0 if x equals to 1. In part A, evaluate the limit of g of x as x is approaching to 1 from the positive side, and the limit of g of x as x is approaching to 1 from the negative side, and then determine whether the limit of g of x as x is approaching to 1 exists. In part B, sketch the graph of g of x and identify any points of discontinuity. So I'm going to start with the second part first. And the reason why I want to start with the graph is because if you've been listening to all the videos and you've been watching for all the lessons I've given you so far, you know I'm advocating a dual mindset almost all the time. And by graphing this, you can see what it looks like. Then when you go back to the algebraic approach and they match, then you've double checked your work. So again, if I look at this in my mind, I'm going to give you, or I'm going to set up a scale. I think 3 should be more than enough for this specific case. Again, I'm just kind of doing this mentally. Now, here's the first part. If I think about the first part of the piecewise function, there are two cases. Why is that? Because there's the absolute value sign. So what I do is I can write down case number 1 at the top here. And case 1 is a positive case. So when I think about the function g of x, I'm thinking about x times, in round brackets, x minus 1 divided by x minus 1. And again, if I simplify this, x minus 1 divided by x minus 1 is going to give you 1. 1 times x is going to be x. Now, since this is the positive case, you want to be mindful. The domain for this function, g of x equal to x, is going to be for x greater than 1. Now, if I draw a line, divide this into 2 columns, in the second case, case number 2, and g of x equals to x times negative times x minus 1, and I'll put brackets around that, divided by x minus 1. So again, the second case is the negative case, and when you cross out x minus 1 divided by x minus 1, which equals to 1, 1 times negative 1 is negative 1, times x, that's negative x. And again, g of x equals to negative x when you're looking for x less than 1. So again, the first piece of the piecewise function became 2 parts. So if I graph this first case, again, here's the mistake I see all the time. If you're thinking about y equal to x and you're thinking about it in all space, that is a mistake because you only graph this when it's greater than 1. So I go back, a little bit of mental math. I plug in 1, which is going to be 1. I draw a circle, which means this is not part of the function. And I draw a line that looks like that. Now, likewise, if I look at the second case, I'm graphing g of x, which equals to negative x. And again, the mistake I see too often is this, all right? You're graphing negative x for all space, and that's not true. You're only graphing this when it's less than 1. So I go back with a little bit of mental math. I plug in 1. That's going to be negative 1. I'm going to draw a circle. Again, these lines could be more straight, but I hope this makes sense. So that's the first piece of the piecewise function. If I look at the second piece, again, this is going to be a point, and it's going to be 1, 0. So I go right by 1, and I stop, and I draw a dot. So this is going to be g of x. So again, part B, sketch the graph, identify any points of discontinuity. So by inspection, you can tell that the function is going to be discontinuous at x equal to 1. And again, you could talk about the 3 conditions, the limit, f of 1, and if they equal, right? Now, I'm going to go back to part A. Let's write down part B. Let's go back to part A. So in part A, they're asking what is the limit of g of x as x is approaching to 1 from the positive side. So in a different color, I'm basically taking my right hand and I'm tracing this function. And I'm asking myself, what is the corresponding y value? And again, remember in limits, you're not there. You're almost there. So in this case, the right limit is going to be 1. Now, likewise, if I look at the limit of g of x as x is approaching to 1 from the negative side, let's use a different color. You can take your left hand, trace the function, find the corresponding y value, and it's going to be negative 1. Now, again, I'm going to show you a shorthand to write some of this. You could always write the longer answer, but the faster approach if you want, you can write down since the left limit, so LL means left limit, does not equal to RL, which is the right limit. Therefore, the limit of g of x, as x is approaching to 1, equals to dne, which means does not exist. I hope this makes sense.